Everybody, hi, welcome. Thank you for joining us today and sitting in on our 3-axis to 5-axis webinar showcasing Fusion 360 and PowerMill. Our goal today is to give you a solid understanding about how Fusion 360 and PowerMill can help you increase your efficiency while maintaining the highest quality standards for your finished work pieces, ultimately improving your workflow. We're going to try and keep this short, guys. We're going to try and keep it around 45 minutes and then have a question and answer section at the end. So feel free to ask questions during the webinar. And whoever's not talking, we will keep an eye on the chat and try to either respond back or save that question to the end, and we can answer it live during that session. So who do we have here? Let's take a look at the speakers. First, starting on the left, we've got Jeff Stelling. Jeff Stelling is a technical consultant and has been for the past 2 years with SolidCAD and AMS 360. He's been supporting Autodesk products, mainly PowerMill, Fusion 360, and FeatureCAM, but specializing in post-processor development. Before his role as a technical consultant, he was a CNC machinist programming and running 5-axis machining centers for complex molds and dies for 20 years in the industry. Next, we have a very special guest, Mr. Chris Crane. Chris Crane comes to us from the Autodesk technical, the technical sales team, and he has worked for Autodesk and formerly Delcam for 15 years, specializing in the Autodesk manufacturing industry. The Autodesk manufacturing product offerings. Prior to that, he worked in industry in the automotive, aerospace, and machine tool applications. We're very excited to have him on today. He is going to talk to us about the future of making things that Autodesk is showcasing right now. And then the last one on the right is myself. My name is Mike Belanger. I've been working as an Autodesk partner with SolidCAD and AMS 360 for just over a year now as a sales consultant. Prior to that, I worked for almost 6 years at Autodesk, formerly Delcam, as an applications engineer, specializing in the CAM offerings. Before my time as an applications engineer, I was a CNC machinist, programming and operating 5-axis machines in the mold industry for about 15 years, using PowerMill pretty much that whole time. All right, so I kind of like this slide. This gives you a good view about what SolidCAD is and a bit of a roadmap, how they got to be where they are right now. So for 25 years, SolidCAD has operated as Canada's largest technology and professional services provider. We have over 150 employees nationwide, nearly 40 of which are dedicated to manufacturing. So that's where we come to our team. Inside the manufacturing team, we have our team, which is the advanced manufacturing team. Now, recently, SolidCAD has focused on aggressively growing this advanced manufacturing team by acquiring AMS 360, which is where Jeff and I come from. And we were acquired last November. And then Landry Tech, just this April, was acquired to cover more of the French region and help grow our technical know-how. In addition to that, we've also hired 2 more individuals, and they actually specialize in program and process automation. So we're really pushing that automated side of the software. The 12 pictures shown here represent the largest advanced manufacturing team specializing in the Autodesk Make portfolio in Canada. I'm very excited to be a part of this team. So what does our advanced manufacturing team offer? Well, of course, we offer the software itself, but it doesn't just stop there. We are a full service team that offers continued support after you purchase your product, also specializing in services, including training, consulting, custom post processors, building process automation, and the list goes on. Basically, we're not here to just sell you software. We're here to partner up with you so we can both become successful together. I mentioned training there. The training that we offer can be a standard new out-of-the-box training course that a new user would use, but more often we find ourselves doing a custom training class. We can tailor any class to include the exact material needed for your workspace. We can do it on site, in your environment, to run tests on your machines, at the shop floor, to give your attendees the most out of our time together. So, before we jump into our product demonstration, I'm going to hand it over to Chris Crane. He will talk about the future of making in the design and manufacturing sector of Autodesk. Chris?
Thanks, Mike. I trust you can hear me okay.
Loud and clear.
Perfect. Hi, everyone. It's great to be here, and many thanks for spending your time with us today. This brief presentation I'm going to give is going to help you understand how Autodesk sees the market and give you some insights into what we're doing to help our customers enable their competitive difference. Really, what I want to cover is three main topics. I want to cover the manufacturing industry trends, the opportunities for your business by evolving through disruption, and how Autodesk can help you realize these opportunities to achieve better business outcomes. Okay, I hope this presentation will help you maybe think about some of your challenges and where we could potentially partner and work together to find solutions. Let's think for a moment of all the current initiatives and pressures we are all facing in our day-to-day business and personal lives. We're seeing challenges from increasing world population, the impact of an aging workforce, but opportunity with the new digitally native workforce and automation. Challenges from climate change and the drive to eliminate detrimental environmental impact, but opportunity with the new means of manufacturing and materials. Challenges and increased global competition and rise of new disruptive business models, but opportunity with digitalization and infinite cheap computing power. These macro industry trends are impacting manufacturers in three areas: the nature of products, the things you make, the technology available to help you make these things, and the nature of the work your people will be asked to do. The things you make, whether products or buildings, need to be better suited to human needs. They need to be more customized, more configurable, and more connected, and ultimately more valuable to the customers and the producers. We are seeing the rise of product as a service, the Internet of Things, as being a way to collect information and mine it for insights that create more opportunity for better products and additional revenue streams. These challenges are not news to you. They're well documented in many publications and are a driver for the Industry 4.0, digital factories, and many other initiatives. At best, they will be felt in the disruption across supply chains. At worst, we will see companies disappear. The question the manufacturing community is asking is, what can I do to stay competitive in the face of this disruption? The reality is we have had to look at our own business in the same way to see opportunities from the disruption, with more agile startups with no legacy business model to consider are trying to lure our customers away. The rise of cloud-based solutions, software as a service, and changing to a subscription versus a perpetual licensing model. At Autodesk, we ask ourselves, what can we do to help manufacturers stay ahead in these changing times and turn it into an opportunity for them? We see evolving through disruption. We see it as evolving through disruption. For example, when I tell people I work for Autodesk, they immediately say, oh, the AutoCAD company. And yes, that is true, but Autodesk is much more than that. We just started disrupting and democratizing the market 39 years ago when the PC created the opportunity to move CAD off the mainframe and onto the desktop. AutoCAD disrupted the design, drafting, and engineering world, and the CAD revolution began. 39 years later, even as a 60 billion market cap company, we're still disrupting the market and growing like a startup. We disrupted the media and entertainment industry with Maya and 3DS, and we believe our solution to how to make things will be manufactured in the future will have the same disruptive, positive impact in manufacturing. Through our worldwide engagements, common customer initiatives, we see our smart manufacturing, sustainable manufacturing, and lean manufacturing. Within those are the goals that matter to the business. We are here to understand your journey and the business goals that matter to you. We recognize that you may be facing challenges such as innovation, collaboration, digitalization, connectivity, and skills gaps. To help you with meeting those challenges, we are achieving, excuse me, achieving your goals. Autodesk invested in advanced manufacturing to automate your manufacturing processes and knowledge, enable AI design. At Autodesk, we call this generative design, catalyze innovation across disciplines using a single cloud platform, to connect your data and reduce non-value-added processes to aid supply chain agility, embrace new marketing, new manufacturing processes and materials. By implementing these Autodesk capabilities, our customers will have been able to overcome their challenges to achieve their business outcomes, create better products, win more business, improve operational efficiency, and enable increased innovation. We have the broadest, most comprehensive, best-in-class manufacturing solutions available today, and our customers are benefiting from the expertise of our people, with over 700 software developers, plus our expert technical consulting team and growing specialized local partner network. We have over $1 billion invested into the advanced manufacturing solutions, and our global technology centers focused on advanced manufacturing innovation. The Autodesk Technology Centers are where the future of making things take shape, with locations in San Francisco, Boston, Toronto, Birmingham, Munich, and Melbourne. The Autodesk Technology Centers are committed to exploring the future of making, from architecture, engineering, and construction to manufacturing and generative design. Our network brings together industry, academic, entrepreneurial communities to create a shared vision of the future of making things. Thanks a lot, guys, for spending your time with us today. As a next step, it would be great to explore how do you see the future of making things. We could do this by organizing a discovery workshop, scheduling a follow-up visit to one of our technology centers. This can also be done virtually, and also by committing to a collaborative agreement to see, you will see the right, see on the right an interesting, excuse me, working with Autodesk Advanced Manufacturing Team, engineers, we want to partner with you and explore what we can make together. Thanks very much, everybody. I'll turn you back over to Mike.
Thanks, Chris. That was great. Let me just steal back presentation here. There we go. I trust you can see my screen now. Okay, so next I'm going to hand it over to Jeff here just for a moment, and he's going to explain what he plans on showing you today in Fusion 360 during his demonstration.
Thanks, Mike. Thanks, Chris, for your presentation, and thanks to everyone for joining us today. My agenda today is to explain what is Fusion 360, connect the manufacturing, what it is, how we can benefit from it, parametric modeling, how we can benefit from that and utilize that in our everyday workflow, give you a quick three-axis overview of the toolpaths offered in Fusion 360, and then a 3+2 and 5-axis overview. And the ease of use is to create 3+2 toolpaths and 5-axis toolpaths. Okay, next. So
there we go.
What is Fusion 360? Fusion 360 is an integrated cloud-based CAD/CAM engineering tool that can be collaboratively used within your team or any parties that are given access to your files. Whether you're an engineer, a designer, or a machinist on the shop floor, you can all have access to the same files, up-to-date revisions, and be connected at all times, ensuring that production is never halted and allows users to collaborate anytime, anywhere. Changes can be made to designs automatically and be available to the shop floor to continue the machining process.
So I'm going to apologize real quick. It looks like we have a slide out of place. I think that's what you were supposed to be looking at right there, Jeff. That's my bad. Is this the slide that you need now?
That's the just go to the next one. Sorry about that.
Yep, there we go.
Okay, sorry about that little hiccup there. So cloud collaboration.
Okay. You know what, Jeff? Let's rewind. A bit of a hiccup on our end. Basically, what we wanted to talk about right away was what Jeff was going to show with his Fusion 360 demonstration, and then I'm going to give you a brief overview on the PowerMill, and then we're going to jump into Jeff's half of it. So basically, once Jeff is finished with his Fusion 360, I'm going to jump into PowerMill, and we're going to talk about just some of the things that set PowerMill apart from its competitors. We know that it can do all of the normal things, and it actually does it quite well. But we're going to talk about the ease of use, some of the advanced 3+2 and 5-axis editing. We're going to talk about full control of your 5-axis toolpaths, and then safety, verification of your toolpaths, your holders, and your machine tool. I'm going to touch on some very simple automation to help you gain some efficiencies throughout your work day. And now that I've corrected my flow here, I'm going to hand it back over to Jeff for his portion of the demonstration. I'm sorry about that, Jeff.
No problem. It's okay. Okay, just go down a couple slides.
Right there?
Yeah.
Yeah.
So cloud collaboration, what are the benefits of the cloud-based software? Well, you can quickly access files across your team of programmers, designers, machinists. You can have your tool databases, toolpath templates, post-processors, machine configurations, all stored on the cloud. That way, everyone has access to them right when they need them. They're no more going around the shop asking, what's the latest post revision? What tool database do we need to use for this machine? Everything is right there to your availability. Setup sheets in the cloud. As soon as you're done programming the job, you can create the setup sheets. They're uploaded right to the Fusion team. Again, anyone, anywhere can access these and get started right on the project right away. And also markup. You can send a link. You can access your files on a tablet. If I want to send a model I just designed to Mike, he can look at it on the tablet, make any changes you want, marks it up, send it right back to me. I can make these changes right on the fly within minutes. To talk a little more about the cloud-based, I'm going to jump into Fusion here. I'm going to steal this share here. Can you see Fusion?
Yeah, I got you, Jeff.
Okay. So just a quick overview of what Fusion 360 is. This is the layout of Fusion 360. Up here is where all your teams, you can be part of multiple teams. You can be teams with your customers, teams with your employees in your company. Right here, you can see I have my SolidCAD team. Oh. And then right here is where you can store all your projects. So you can see I have multiple projects open. And then this is the data panel. And then over here is the workspace. This is my design workspace. As you can see, we have design, generative design, render, animation, simulation, and manufacture. These are all workspaces that Fusion offers all in one software. Okay, I was talking about the cloud-based access to the files at all times. I'm going to make a change on this file, and I'm going to have Mike have it open on his end. And he right away, as soon as I make these changes, he's going to be able to open up the file on his end. The change will be automatically made, and then he can regen his toolpath. So I'm just going to.
All right, just let me know when you want me to steal the presentation, Jeff.
So I'm going to make a couple quick changes here to the model. Sorry about that. And I'll change this one right here too. Forgot to hit OK there. And I'll change this one. So what I'm showing you is how easy it is to make design changes. If your customer contacts you and says that there's been a design change to the parts you're making, we can easily make these changes. And being connected, as you can see, I can see that Mike has this file open already. I've made the changes to this file. So if Mike, if you can share your screen, and we're going to show you exactly how we're going to show you how the ability to have the changes automatically made.
Okay, so you got my screen here. You can see the part that I have. And now, if I go up into, which one is it here again, Jeff?
Sorry, Mike, I'm just saving the piece right now.
Okay. And like Jeff had mentioned, I can actually see up here at the top, it gives you a real-time view on what's happening, who's working on the part. I can see that he's just made a couple of changes in real time. So there's no delay. There's no worried about working with an old piece of CAD data.
As you can see,
yeah.
So I was going to say, as you can see, Mike's getting the warning right there that there has been a components out to date, that there's been a change in design, and also on the model, he's getting the warning. So all Mike needs to do now is open up the models. Open up one more, Mike.
Nope, there, right there. Okay.
Yeah, you can just right click on that. Why did it not?
All right, do we need to? I'm going to jump back out and jump in real quick.
Sorry about this hiccup here.
That was this one down here, right?
No, sorry, go into the Fusion team.
Oh, there it is. You weren't, okay, there we go. All right, so obviously we have just a slight technical difficulty here with this. Basically, in the end, what's happening is you can see right here that there are different.
Sorry, I was going to say, go into your design space.
Oh, that's it. So yeah, that's something we forgot to mention here. When you're in Fusion 360, because it's an all-in-one tool, we have number of workspaces available. I was in the manufacturer workspace where you're going to get all your toolpaths. This design portion is where you
now, now you can right-click on the model, choose version.
So even though you're not in that workspace, Mike, it's still letting you know that there's been a change to that model.
Exactly.
And any stakeholders on this project are going to have the same data to work from.
Yeah. Exactly. So if you look here, there's the current version that I'm in, the one that's highlighted. And I can see that this was last just saved by Jeff 2 minutes ago at 2:23. So I can select this, choose OK.
It automatically updates the file. And now if you go into your manufacturer workspace, automatically it's letting you know that these toolpaths need to be regened. Just right click on setup to there, Mike, and generate. And now all these toolpaths are regenning to the changes that I made to the file. So there's no more needing to jump to a third-party software, make the design changes, export it out as a step file, Parasolid file, email the change to the programmer, the machinist, and then reprogram it. Even with the little hiccup we just had, within a few minutes, our model is changed and programmed.
Okay. Was there anything else you wanted to show on this one, Jeff? Or
no, that was it.
Okay.
Minus the few hiccups. I just wanted to show the ability to change. I'm changing the model on my end, and on your end, you're able to receive that new design revision right away and update your toolpaths.
Excellent.
Okay, I'm gonna share again.
There we go. We got you.
Okay, next slide to the parametric modeling.
So that's on your screen now. Okay, so you want
Sorry.
me to, let me go like this real quick.
I'll let you share again, Mike. Okay, so parametric modeling. What is parametric modeling? Parametric modeling is a design method that sets parameters instead of dimensions to specific parts of the model, the entire model, or specific parts of the model. Using this method allows the users to easily change the model while keeping the integrity of the design. This allows you to reuse the same design for multiple projects. In my case, I'm going to show you, I have a vise drawn up and designed using parameters. And I'm going to use it for my first, I'm going to show you how I can adjust my stock in my first setup and then create a second setup using the same vise. So I'm going to share my screen here. Okay, you can see Fusion.
I got you.
Okay, so right here, you could see I have all my toolpaths programmed for the first setup of this part. Now let's say I come from a job shop atmosphere where we did components for tool and mold, tool and die, automation, robot components. A lot of the times you would get parts that had multiples, 10, 15, 20 of the same model. Most of the time, either the customer would let you know that they're all squared up to size and you would program it as so, or you had someone in your shop mill them to a certain size and you programmed them for that size and you just want to put them in one in a vise and one after another. Well, a lot of the times what I've seen is you go through about 15 of them, and then the last 5 are either there's too much stock, that they weren't squared up properly. A lot of the time what you have to do is you have to reprogram that, create a new stock model, and so on. With parametric modeling, I'm going to jump into my design space. And as you can see, I have my stock. That's how I've cut my first 15 pieces. If I jump into my parameters here, you can see I have this vise and my stock designed using parameters. So simply, let's say this stock, my last 5 pieces were, to, sorry about that. Let's even go a little bigger just to show it off. My last 5 details I have were adding a 1/2 inch of extra stock. Now I could set all those up in the vise, mill them to the size of my first 15 that I did, and then continue with my original programs. It's very time consuming. It's a lot of wasted time on the machine. So what I've done just by using parameters, I've added that extra stock. You've seen my model move up in the vise. I'm still sitting on the parallels. I'll jump back into my manufacturer space. And again, it's telling me I need to regen all my toolpaths. Just after a few seconds, you can see all my toolpaths are regenning. And in a couple seconds, I'll be ready to finish those last 5 details. There wasn't any reprogramming. There was no squaring up the extra details on the machine, taken away from the machine time. As you can see, there's all our toolpaths at our new height of stock. And since I'm in this workspace, just start looking at some of these actual toolpaths here. So one thing I want to point out is Fusion, these are all our 2D toolpaths we offer. Adaptive clearing, pocket, these are roughing toolpaths. Facing, the face off stock, 2D contours, slot, tracing, and then these threading, boring, circular, these are all toolpaths to machine holes, circular pockets. And then we have also over here the options for 3D toolpaths. Again, adaptive clearing, pocket clearing for roughing, and then a plethora of finishing toolpaths. I'd like to point out, as I click on each toolpath, I'm not activating the toolpath, but I'm just clicking on it. You can see the toolpath segment and you can see the stock. So as I go down the line, this is called in process stock. It's tracking the stock after every toolpath. I haven't had to add these to a stock model. I haven't had to calculate anything else. It's just as I go down, it adds all these. It tracks the stock. So it's a very good visual tool to see what stock is left over, where we still need a machine. Okay, so that's this first setup. Now, let's say we had to do a second setup on this. I mentioned before that because we use parameters, we can use the exact same vice model. I'm going to go into, I'm going to need to open it up here. So I'm going to show how within just a minute I can get my second setup ready to go. Oh, that didn't quite open that up there. Okay. Okay to that. I'm just going to bring in my vise. It's taking a little longer than I expected. Oh. Okay, there we go. So now my vise is in there. You can see my stock is all set up. Clearly that's not the proper size I'm going to want. I'm just going to shut this off right now. So just quickly, I'm just going to add a couple of joints here. Turn my vise back on. I'm going to flip this over. I'm going to put it offset if I know that I'm just going to guess there's a 1/2 inch of stock on the bottom. I'm going to go into my parameters. Oh, before I do that, I have to break the link. Right, that's a good good example actually. It won't let me make any changes to this vise because it is from another design unless I break that link. So as soon as I break that link, now I'm free to make any changes that I need to. Now if I just go so now I'm ready for my second setup. I'm sitting on my parallels. I've got my 1/2 inch of stock. I'm going to go into my manufacturer workspace, create my setup here. That's the one I want. Now I'm just going to, I know the size of my finished model, so I'm just going to add those in. I know I had added, sorry, my mouse is a little finicky today. And then just like that, my model is set up with the extra stock for the setup 2. Just going to make a quick face mill toolpath to remove that excess stock. That's good with that. Multiple passes. Let's go here. Let's just say, and then within a couple minutes, I have my second setup using the same vise model that I used for my first setup, just by adjusting a few of the parameters. I now am ready to go for my second setup to take off that excess stock. And that's how you can quickly utilize parametric modeling in an everyday workflow in a shop atmosphere. Okay, Mike, I will stop sharing and you can go on to the next slide there.
All right.
Okay, so benefits of 3+2 and 5-axis machining. Well, with 3+2 and 5-axis machining, you have the ability to machine complex shapes. You can use shorter tooling, which gives you a more rigid machining. The longer your tooling is, you're going to get chattering. You're going to get chatter marks on your models, which is going to give you a bad surface finish. So shorter tooling is going to give you a better surface finish. 3+2 and 5-axis allows you to finish a job in fewer setups. The more setups you have, if you have 2, 3, 4 setups, that means you have to pick that job up 2, 3, 4 different times. This is going to allow for error. There could be errors somewhere. If you pick up the job wrong, it's set up wrong. So you're able to get a more accurate finish using 3+2 and 5-axis. So I'm just going to steal the screen there. So I just have this little fancy model here that we just looked at with Mike. I'm just going to show you how you can quickly create a 3+2. I want to machine these pockets on the sides. I've already gone through my 3-axis toolpaths, my roughing, my finishing. All these are finished. You can see I'm tracking my stock. My in-process stock is showing me that all I have left are these holes in these pockets. Now I do already have them finished here, but I'm just going to go ahead and create another one. So I want to create a 2D pocket. So right away, I'm going to grab a tool. No, I'll stick with the 1/4 inch tool. Just by clicking tool orientation, I'm going to select how I want it orientated. Just by that, I don't have to do any measuring. I didn't have to create a work plane. I just select on there. And then I'm going to select my contour. And I'm going to make a couple changes here. Oh. And just like within a minute, I have my pocket ready to rough out. Now it's still loading. There you go. So as you see, now that toolpath is roughed out. So now I can, most likely you might have a print for these, but I'm going to guess that these are symmetrical. So I could create a toolpath on this pocket here and then over here. But what I'm going to do is I'm going to add to a new pattern. I'm going to say circular pattern. And now I just have to choose what axis I want to use. So I'm just going to look at this one right here. And just like that, now I have a toolpath on each of these 2 pockets. And that's such a simple way to create some 3+2 toolpaths there. Now it'd be the same thing if I want to create a hole. Oh, better choose a drill here. Tool orientation. Just going to select how I want my tool to be orientated. Select my holes. And just like that, now I have 2 holes to be drilled on a 3+2 setup. And again, I can add to a new pattern. And within a couple minutes, I now have my 4 holes that I need to drill on each side of my piece. Excuse me. So in a nutshell, that is a very simple way to create 3+2 toolpaths in one setup. Now I have already machined this whole model. I have all my side work completed. Now to look into some multi-axis. Sorry, I just want to look at something here. So Fusion also offers some multi-axis toolpaths. Right here we have a swarf, multi-axis, contour, and a rotary toolpath. Rotary toolpath is more of a specialized toolpath that utilizes the rotary axis of a machine on a mill turn machine. Today I'm going to look at 2 more of the popular ones, which is swarf, and then over here in 3D, steep and shallow. Now this steep and shallow toolpath, that comes from That's the powerful toolpath that has been borrowed from PowerMill, which I'm not sure if Mike will be showing that off or not today.
Oh, we might touch on it.
Okay. So I'm going to just select this toolpath here to show you the benefits. This is a steep and shallow toolpath, just the three-axis motion. There's no multi-axis. As you can see, it's only machined certain parts of the wall and down below in the center here. The reason why that, clicking too fast. The reason why that is down here, I put a collision on the shaft and holder of 40 thou and 200 thou. So what Fusion is doing as it calculates, it's looking at those values, and this is telling me that to stay with those values and avoid collisions, it can only machine these certain areas. That's fine. I could go and put in a longer tool. I could adjust my tool right on the fly, but then a longer tool, the finish isn't going to be as good. We're going to get a lot of chattering, possibly some gouges. So a better way to machine this pocket is using multi-axis. As you can see, now I'm getting everywhere on this pocket, everywhere in the bottom corners. And to show you how I did that, all the values are the same. I'm just going to jump into the multi-axis. In this steep and shallow, you have the option for collision avoidance. What collision avoidance does is it will keep the toolpath as a 3-axis as much as possible until it gets in that value range that I put on my shank and my holder. Once it's going to violate that value, it will now automatically tilt away to keep that value in a range. And just to show you exactly how that works, I'm going to simulate this. Might just take a couple seconds. Excuse me. Okay, so now we're ready to simulate. I have a few options in my simulate. You can do a comparison. So what the comparison will do will show you what is in range, what's finished, if there's any gouges, if there's any remaining stock. I can just have the operation, and I can have it show a different type of material. Right, I'm just going to keep this on operation. I'm going to slow this down a little bit, and I'm just going to speed it up. So here's all our 3-axis toolpath, the 3-axis vertical. Right now, it's not going to violate the shank or the holder clearance. So I'll just keep moving just to speed this up a little bit. Don't want to be taking too much of Mike's time. And I'm going to stop this as soon as we start, which I think right about here. See there, now it's tipping away. And you can see that holder is getting right down in that pocket, machining all those bottom corners, keeping those values that I put on my shank and my holder. It's a very powerful toolpath. You're gonna get a good, nice surface finish. Your tool is gonna stay rigid. Speed that up a little bit. And that just simply, that was one of my favorite toolpaths. Well, from PowerMill. You can use it all the time. That collision avoidance, it can be a lifesaver. It allows you to use short tools most of the time. And now I'm just going to show you a swarf toolpath here. Swarf is under the multi-axis. This is another toolpath where you can tell it what type of sideways, what type of tilt you want on it. And all I'm going to do, I'm just going to simulate this, cancel that. Give it a second to load, and you'll simply see, let me slow this down. You'll simply see the tool is staying along these walls here of the part. If we couldn't use a multi-axis, then we would most likely have to either set up on a 3+2, rough this out, maybe pick it out a little bit, or even worse, set it up, do a second setup, and machine that, and then you take the chance of this not perfectly blending in with your toolpaths from your 3-axis setup. And so right there, that's two of the I would say those are the two of the most powerful multi-axis tools that Fusion has to offer right now.
Absolutely, two great tools that they've added into this software, and it's only growing. It's such a young product that they're putting so much technology in. I love to see all of these advancements in it.
Yeah,
so,
like Chris had mentioned, they have one of the largest teams of developers, and Fusion is constantly updated. I think just yesterday or today there was an update. And another benefit of it being a cloud-based software, you don't have to be going and looking, seeing if there's an update that you need to download. It automatically updates you. You open up Fusion, turn it on, and it'll let you know if there's an update or not.
For sure, always working with the latest and greatest version. That's very important. So if I think that brings you to the end of your segment, eh, Jeff?
That is my segment. Thanks to everyone for sitting through that, minus the few hiccups that we had. Yeah.
Yep. Couple technical difficulties. It's the age we're living in now, but
the downfall of live webinars.
yeah. Nope, that's all good. And what I'm going to do real quick here, Jeff, is steal presentation back from you. And if you're good with that, I'm going to jump into my half of it. Now, just real quick, I know that we're going over on time a little bit, so I'm going to kind of speed through some of these items. I have a lot of things pre-created, so we won't have to wait too much. But I'm gonna kind of truck through all of this, and if there are any questions, again, toss them into the chat. We can address them on the fly or at the end. So, yeah, basically this slide. I do like this slide. It kind of gives a really broad view on what PowerMill does, because anyone that does use it, and someone who's experienced in PowerMill a lot of times doesn't realize how much flexibility and function it actually has. So the one thing that we all know, it has its high-speed machining. You do your vortex roughing, your high-speed finishing strategies, all your strong toolpath editing with PowerMill, transitioning from the Fusion side, that is. It also does your 2D milling, right? Just like any CAD package was, but it has that feature detection. It does your drilling quickly. It has your pocketing, chamfering. It does your 3+2 machining. So this is where we start getting into some of the more advanced and big benefits to PowerMill. Okay, you have the tools like your dynamic machine control, your stock models, your process control, all that flexibility. Then you have your 5-axis finishing. Right, that's kind of PowerMill's bread and butter. That's where they kind of set themselves apart from the pack. You know, you got your swarf finishing, your tool axis control. That's the big one for me. That tool axis control, the ability to force it to do what you want, right? Motion optimization, okay? There's also a small mill turn package in there. So you can do some basic mill turn if you need to. There's also a plugin for robot. We're not going to be talking about that today, but just so you know, if anyone does have any questions, absolutely reach out. It can control actual machine robots for milling, trimming, polishing. It even does additive manufacturing, because you can get a welding head for it, and then some subtractive manufacturing if there's a spindle on the robot itself. And then there's the big one that's becoming more and more prevalent is the automation. User-defined macros, machining templates, and custom toolbars. But honestly, it doesn't just stop there. The automation can be so far customized. PowerMill has left their platform open to be able to create your own plugins, to be able to create your own processes. You can have a third-party software interact with PowerMill, and you can drive it. You can drive it to do processes that you may not even realize is available, and we'll talk about that more on another day. So let's just jump quickly into my demo, what I want to show. And like I said, I'm gonna try and go through this fairly quick to try and save us on time here, and we'll get into it. So as you can see here, we have the PowerMill layout. It's similar to Fusion in the sense of, you know, we have the Explorer along left-hand side. We have the tabs along the top. That's all fine. And if you look through the tabs, there's just each set of specific function in each one. Okay. The Explorer, I've always liked that because what we do have is an ID and information on everything that you have currently created, from toolpaths, boundaries, NC programs, which is posted code, so on and so forth. If I go over to my Home tab and take a look at the Home tab right there, if I take a look at the toolpaths, I can open up the strategy selector, and right away I can see all of these options I have for finishing. And I'm not talking about these options because these are only folders with extra items in them. As I click on each one of these folders, there are a tremendous amount of options to create toolpaths in PowerMill. So really the possibilities are endless. There is, and the nice thing that I do like, let's just say, for example, these finishing strategies, you can make a finishing strategy, 3-axis. Then all of a sudden there's an issue with some kind of collision. If your machine has capabilities, a small edit inside that 3-axis toolpath, you have a 5-axis toolpath that quickly. Okay. Let's jump into the technical portion of it. So right away, you're going to see some folders along the left-hand side here. If I look, there's my set of roughing toolpaths. Nothing too groundbreaking. PowerMill does it. PowerMill does it very, very well. Jeff talked about the different styles in Fusion 360, the adaptive roughing. PowerMill has that as well. We can do the adaptive roughing. We can do the stock management. PowerMill has what we call stock models, where it can manage stock and responsibly manage this material with whatever process we need for the next step, right? And with the stock model, you're going to see an actual representation of the material left behind. As you can see, there's maybe some stock right there, but I'm not going to dive into these toolpaths. I just want to make sure everyone's aware that it does do roughing. It does do it very well. It does rest management, so it's only attacking the areas that need to be attacked. Okay. Turn that off. All right, so I have some more flat toolpaths here, again with the 3+2. So this is where we start kind of setting ourselves apart from some other CAM packages. So this isn't too groundbreaking, but here we go. Here's our flat toolpaths. Now, the one thing that I like to notice about these flat toolpaths are the leads and links. So in PowerMill, when you create a toolpath, the toolpaths actually come up this green color, right? And then these orange moves are the leads and links. And if we have a toolpath that looks something like this, you can see that there is a jumping, like a link move over from one side to the other. If we're not happy with that move, all we need to do is open up this form, change it to whatever style link we need, and hit apply. It updates the toolpath almost instantaneously, depending on the toolpath size. So we don't need to recalculate any toolpaths. We just need to update the toolpath with the new leads and links settings. And that goes for the lead ins, the lead outs, which are these extended moves, and then the joining moves there. Okay. You can also update your safe heights. You can update your start and end points, all with a simple update and calculation inside this form without ever having to recalculate a toolpath. Now, if we're talking about this toolpath, sure, it takes 5 seconds to calculate or less. But if we're talking about a toolpath that took you 20 minutes to calculate, that's a serious time savings. Okay. Next on the list, I'd like to talk about, if we jump into here, some collision checking. So I'm going to go right over here to this toolpath. And as you can see, we've got a 3+2 toolpath. If I do a quick simulation, everything looks fairly good. Toolpath, or the tool is going back and forth, back and forth. But what we didn't notice is that the holder is actually colliding. And in PowerMill, you notice that you are getting a white check mark. So maybe even a new user would think that this toolpath is perfectly fine. Well, it's not necessarily fine. PowerMill has different levels of verification. All right, so just a real quick look at that. If you have the yellow, that means this toolpath is unverified. White means it's gouge free, which is essentially the cutting portion of the tool. I think I flipped my screen right there. That's the cutting portion of the tool. The blue check mark is telling me that the holder and the shank are both verified as well as the tool. Red is obviously telling me that there's a violation of some sort. And then this green check mark is telling me that I have full verification against everything, including the machine tool, which we'll talk about in a quick second. So the reason I like to highlight this is because it's a very obvious sign that something is, good or not good inside the software. So I'll minimize that. Now on my home tab, if I quickly do a collision check on this particular toolpath, I should see a violation. There we go. Collisions were found involving the cutting moves. So I click OK, and I know I have a problem. All right, the collisions were involving the cutting moves. So what I'm going to actually do is use my colliding sections. I click on my colliding sections, and it's going to tell me where the problem is. All right, go back, run that collision check again, and it's actually updated itself. Let me jump back because I'm going to show you something different. Let's go into this tool path. Same problem, same tool going into the same areas. We have collisions. So we're going to use the dynamic machine control. And when we use the dynamic machine control, I like to use the machine tool along with it. So I'm just loading up my representation of the CNC machine that the job will be run on, setting a couple of variables to ensure that the environment is set correctly. And then I'll place the tool down in one of these areas. In the dynamic machine control, we have the option to move the tool around, get an idea of where the head, where the tool, where the holder is going to be. And then I can make edits by either adjusting the angle of the spindle by using these grab handles, or using the machine tool position form and actually moving the slider bar, or typing in a value. Maybe I want a nice 45-degree tilt. So once I'm happy with the adjustment that I've made, I simply accept those changes like that. And then I can run the verification again. As you notice, the check mark has gone back to yellow because we need to re-verify because we changed the tool axis. And now we have no collisions. Quick gouge check. And we have the blue check mark. Didn't have to recalculate the tool path, didn't have to create a new tool path. It just worked. All right, I'm gonna jump over real quick. Let's take a look at some other items. We have swarf finishing. Jeff was showing swarf finishing. PowerMill does it as well. They do it very well. And some other 5-axis tool paths here. So we have this pocket. We're doing a corner finishing down in the pocket of this job. Another option that we have inside of the software is creating a curve and driving the tool axis through that curve. So by simply making one change, inside the toolpath creation, we go from a toolpath that goes straight up and down and possibly violating the holder. As you can see, it looks fairly rigid. This is a simple 3+2 toolpath. And with the flick of a switch, we now have a tool that's actually leaning away from all the walls to ensure safety, to make sure we don't have that violation. Okay. Next example, we have a steep and shallow. Sound familiar? It was in Fusion 360. We have that option, Fusion Obviously got that tool from PowerMill, very powerful, very easy to use tool. So if we have our steep and shallow, we're cutting down these walls. We try and go all the way down, but the holder itself ends up colliding along these walls right here, which is fine because we know that we have options inside the toolpath. And the first option I use is called from a point. So on the tool axis page, which is where we make our changes, I'm going to choose a point, an arbitrary point with an X, Y, and Z value up at the top, and the tool axis is going to drive through that point. But there's going to be an issue. As it goes around and continues to machine, it is going to have a violation down in these edges down here. Too close to the edge. And I can actually show you through the toolpath verification, collisions, models there. Okay, so when we end up with an issue and there's still a problem, in this particular scenario, you can leave this setting the same or jump to what Jeff hinted to, which was the automatic collision avoidance, another tool that migrated from PowerMill to Fusion. So you can see how these different platforms are playing well together in using resources from each other. That's just another reason that having a development team in a company this big, how it's such a benefit for everybody. All right, so there we go. We see that we do have collisions, and this is what I like. First things first, I noticed that I have a lot of poor leads and links. Well, I want to clean that up because that's clearly inefficient. So I just jump into my links page. I change these to, let's just say a circular arc. I hit apply. And just like that, my toolpath becomes very efficient, but I see all the problems that I'm facing here. All of these red areas are the spots on the toolpath where it collides with the holder. So to remedy this, what I did was regenerated this toolpath, but I used, like I just mentioned, automatic collision avoidance. So a quick change there in calculation gets me a toolpath that now automatically tips away. It's not from a point, it's not to a curve, it's not lean lead. It actually just automatically tips to ensure that there are no collisions within the parameters of what I've asked. I'm gonna show one more thing, and this is just lending itself to the editing portion of the software. So we have a toolpath that cuts this whole domed or piped area right here, but I know that there is a collision in these tight corners because of the size of the tool and the edges that are rather vertical or steep, should I say. So I'm gonna do the same thing where I run this collision checking, and like it did before, it's gonna show those colliding sections. And those colliding sections make it really easy for me to identify the bad areas, as we can see right here. And all I have to do is put myself into a top view and modify these with a tool called Edit Within Region. So I'm going to select my region by just creating a polygon like that. And then I'm going to change the direction. So I'll say fixed direction of right there. So I'm just going to choose the view that I want to be in. And basically what PowerMill is going to do is the exact view that I'm in, it's going to choose that as its new Z vector. After I do that, put a little blend distance of, I'm in metric, so I'll say 10 millimeters. I'm going to hit apply, and you can see that colliding section is gone immediately. But what does it look like? Okay, so the tool path, as it comes around to the problem area, let's get it going the other way. There we go. As it gets to that area that I edited, you can see the automatic tilt back, and then it continues to go as the toolpath was created. Okay, so a very quick, very easy edit to avoid that collision in a very tight, tricky area underneath the side, severe undercut, and the edit took me maybe less than a minute to do, as opposed to something like this, where it is colliding. So right there, we have our collision. It rubs against the holder and goes. So the amount of movement, the amount of change is minimal, but just enough to avoid that collision. Makes it that easy. All right. One last thing that I'm going to show is going to be the NC program verification. So what we've done now is we've gone through, we have our toolpaths, they're all safe. But how do we know that the machine isn't colliding into the job or itself, or possibly even hitting a limit? What we do is we take the toolpaths that we need, and I'll just take a couple right here. And I know I'm going to have a problem with this one because there's still collisions on it, so I can show you what it's doing. And I'm going to dump, let's just say, 2 of these toolpaths into an NC program right there. Inside an NC program, I can verify the whole environment, including that machine tool, like I mentioned. Now, the great thing about this is that it's considering everything like I just mentioned. A regular PowerMill toolpath verification doesn't care about the machine limits. This does. Everything's built into the machine file in the post, and everything communicates together to get you the best result. Okay. So after I'm done this one thing that I'm showing you, and you can see it starting to populate the list, I think we're gonna open it up for any questions. And if there aren't any, we can close everything up and let everybody get on with their day. All right, so there we go, machine verification. Now, I see that there's 3 issues. One of them is a warning, 2 is a problem. So I'm just going to double click on that first problem, and the tool is going to go immediately to that bad spot. All right, and there's that problem area that we already knew about. I didn't make the edit there, but I know what the issue is. Next one. Give it a second while it's thinking. Okay, and there's the second collision. Gouges were found, it involved the cutting move. So obviously there's some kind of gouge on the backside there. At this point, what you can do is jump back into your editing tools, use your dynamic machine control, use your edit within a region, and get that safe toolpath, repost the code, get the safe verification status, and you have your safe to run toolpath, which you could run lights out because you have that extra assurance. Like I was saying, we were running obviously behind. I think I'm going to wrap it up at this point. There are some other topics. If anyone's interested, we can talk about them at a later date. Shoot us some you can shoot us an email if you'd like. Let me do this. And if there are any questions, we can address them right now. I see a couple people have filed out. I know that there were some that had prior engagements starting around 3, but if there are any questions, by all means, please toss them into the chat. We can expand on anything, or even take down our email addresses, and if you can forward them, you can forward your questions to us if you want further information on anything or a demonstration. We'd be happy to engage with you there. So.
Yeah, we're not seeing any questions, Mike.
Yeah, nothing, and that's fine. What usually happens when we do these webinars is you'll get interaction afterwards at the through email or even phone call I've gotten before, so that's all good. So yeah, if there are no questions, I guess what we can do is end the session now. Thank you for taking your time. I know everyone's time is very valuable to sit here with us and watch what we're doing. And it looks like there is something in the chat here. Good job, guys. Okay. Thank you.
Yeah, thanks everyone for showing up.
Yeah. Thanks for everyone showing up, spending some of your valuable time with us. And yeah, no questions coming in. So what we'll do is end the webinar now, and feel free to reach out to us in the future if needed. All right. Have a great afternoon.
Thanks, everyone.